regulating the amount of air extracted from the engine. The output of the slave valve is routed to a flow-limiting venturi. The venturi limits the maximum amount of air that can be extracted from the engine under any circumstances. The bleed air is now routed through plumbing into the wing center section. Here it again branches, with part of it being supplied to the air cycle machine and the remaining portion routed to a hot air mixing valve. The air cycle machine consists of an air-to-air heat exchanger and a cooling turbine. Even though they're actually two separate units bolted together, they function as one unit and are usually referred to simply as the cooling turbine. Bleed air supplied from the flow control valve is first routed to the heat exchanger, where it flows through the heat exchanger core. An inlet located on the wing center section leading edge supplies ram air to the exchanger, which flows through the outside of the core. This air will eventually exit the aircraft through an outlet on the lower surface of the wing center section. During this time, the inlet ram air, passing outside the heat exchanger core, will extract heat from the bleed air. This process is similar to the operation of a radiator of an automobile. After passing through the inside of the heat exchanger core, the bleed air is routed to a special type of duct called a scroll duct, and then to the cooling turbine impeller. The flow of air across the turbine will cause it to spin. This action will result in a tremendous decrease in temperature in the bleed air. Without going into laborious detail in the process, it may be explained simply as follows. Spinning the turbine, especially at higher speeds, requires energy. Energy in the bleed air is present in the form of heat and pressure. In performing the work of spinning the turbine, the bleed air must supply energy. Since its energy is heat and pressure, it becomes cooler as its energy is expended. During this time, the bleed air is also allowed to expand, which results in a lowering of pressure and further reduction in temperature. The turbine wheel is connected on a common shaft with an impeller fan. As the turbine spins, so does the impeller. The impeller draws air through the exchanger inlet and increases the total airflow through the heat exchanger, especially while on the ground where ram air is at a minimum. The inlet duct to the heat exchanger also contains a blow-in door. This unit is installed so that for if any reason the normal inlet were blocked, the impeller could still draw air from within the wing across the heat exchanger.
An important concept sometimes overlooked by mechanics when troubleshooting the heating and cooling system is the distribution ducting and plumbing. There's only one cabin air sensor, only one mixing valve per side, and one set of controls in the cockpit. Any write-up that concerns one part of the aircraft being hotter or colder than another almost always has to be related to the distribution plumbing. All of the components that produce and regulate the introduction of hot and cold air into the cabin depend upon the distribution ducting and plumbing to evenly distribute air through the cabin. Hoses and ducts are sometimes knocked loose or crushed during other maintenance activities, especially in the cockpit area. An overall lack of cooling or heating ability sometimes means that hoses or lines have been left disconnected or loose in the wing center section. All told, a great number of problems with the environmental system often involve nothing more than leaks in the distribution plumbing. Now let's return for the conclusion of our program.